Hello, everyone, and welcome to this talk about Compose Hot Reload. My name is Martin Brown. I'm a developer advocate working at JetBrains, covering all sorts of topics like Kotlin multi-platform, Compose multi-platform, Emperor, and related areas. And I'm really excited to show you Compose Hot Reload today, which is one of the most exciting developments that we've had in Compose recently. And there's really no better way of showing you what this is than to just go straight to the IDE and demo it. So that's what we're going to do. So we're going to go to the demo. I'm going to use the Kotlin conf for this, which we rewrote for this year. Has a nice brand new design. It's a great KMP and Compose multi-platform sample, so you can have a look. And I'm going to start the JVM run configuration, which runs it on the desktop target. This is an important part of the talk because this is the only time that I'm going to start the application during the talk, and we're going to do everything else with this one instance of the app. As I'm running this, and I drag the window around a bit, you can see that there's a little widget in the corner that follows it. That's the dev tooling for Compose Hot Reload. That's how we know that it's turned on. And we can open this to see the recompilation state and how many times we reloaded and things like that. But let's see what Compose Hot Reload actually does. So we can hop around the app a bit, and we can go to the info screen, for example. And here we'll see that there's a lot of padding between these items. So these items are a bit too far from each other in all these directions. So we can hop over to the code. We can go to the info screen. And let's say that we want to change this spacing, which is the vertical spacing between items. And I can change this to some new value. You'll see that the dev tooling kicks in with a little orange loading thing, and suddenly the items are a lot closer to each other. And of course, we can do this for these items down here as well. These have 24 dBs of spacing. I can edit that to 12 and watch this closely. So that's the current distance. And I'm going to hot reload, and now they're a lot closer to each other. We can, of course, do more interesting edits than this as well, because it's one thing to be able to edit constant values. We want to make more significant edits to our code, ideally, as well. So let's, for example, try removing a function call from the composition. So we have these three social icons down here. I'm going to select the first one, and I'll remove that from my code. Save that again. And as you can see, hot reload triggers. And now we just have two of them. Let's do something even more interesting. We have a separate composable component for each of these icons down here. And I'm wondering if the contrast is good enough here. We're going to switch to dark mode in a second, and that will help. So let's say that I want to change the structure of this, and I want to show the name of the platform next to the icon. So I already have a description passed in for the content description. So let's add a piece of text and use that same description there. And let's wrap this in a column so that we have some kind of layout. So this is, again, a more structural change, where we're going to have a new piece of layout inside our Compose code. And of course, we need to apply all of these modifiers to the root now. So I'm going to move those from the image up to the column. And if I save this and let it reload, we can see how I'm doing so far with my UI change. It's taking a moment, but it will reload. And as you can see, I'm missing a couple things. So first of all, the text doesn't fit within this 64 dp size. So we probably want to make this a bit larger. And the other thing is that I want to center this within the view, right? So I probably need some horizontal alignment. And if we let that reload, we'll see that everything pops into place. So not only can we edit basic things like constants, we can also make some more exciting changes. We can introduce new layouts. We can remove things that were previously called as part of the composition. And for one more thing before we discuss what's happening here under the hood, let's also create a brand new structure in the code. So let's say that I want to extract this row, which contains the two social icons. I can refactor this into a new function, call it something like social row, make sure that it's a composable. And let's change something so that we know for sure that we reloaded the code. Let's give more weight to one of the icons, just as an example. So as that happens, we'll see that hot reload triggers again. The UI reloads after compilation is complete. And now one of our icons is twice as large as the previous one. So we're not restricted to editing bodies of functions or anything like that. We can even create brand new composable functions. I could change the signature and so on and so on. And hot reload handles all of this for you, making it a lot easier to iterate on your UI code. And of course, we also preserve the state of the application as much as possible, so you don't have to restart your app and then navigate to the correct screen. We stayed on the same screen the whole time that we were doing this and just saw the edits happening in there. How do you set up hot reload? Well, it's basically just adding a Gradle plugin. So hot reload is a Gradle plugin that you can add to your project. And once you add that, your JVM desktop target will have these hot reload capabilities. Let's talk a bit about how this works. And for that, we're going to go back to the slides real quick. When you normally launch your application, you use a build tool. We're going to assume Gradle here, but Emperor actually also works with hot reload. So your build tool launches a JDK for you, like a JVM, and loads your application's code into it. And this app launch is where we add a lot of extra configuration and a bit of magic to make hot reload work. So first of all, we make sure that the JVM you're running in is the JetBrains runtime. This is our own fork of OpenJDK, and the reason why we use it is because it contains a magic feature, which is called DCEVM. It's an advanced way of redefining classes at runtime. And basically, our JDK fork happens to be the only one that implements this proposal, which is great because we're building on our own technologies here. So that's what hot reload is going to use to reload classes. Then we also inject a Java agent into the same process, which is where most of the core of hot reload lives. This is where the real implementation is. Because we need to recompile your code continuously, we also launch a new process, which is going to run recompilation. So still assuming Gradle, we basically just run a continuous Gradle build, which notices file changes, and it will rerun your compilation tasks for you. And when that happens, it will pass back the new compilation result, essentially the new bytecode, to the hot reload agent, which uses, again, DCVM to swap from the old versions of classes to the new ones. This is a very powerful mechanism, and it has very few limitations, so we can swap almost anything here. And then we do a lot of intelligent diffing of the old version and the new version of the code to figure out which exact functions and scopes within your compose code were affected. And once we figure that out, we talk to your application's code, to the compose runtime that's in there, and we invalidate the exact parts of your compose code that have to re-execute so that the code changes are visible. So we reload all code changes initially, but then we also detect which part of the composition has to be invalidated so that you see the code changes as well. And then there are other components that can communicate with the hot reload agent as well. So for example, the dev tooling is, again, a separate process which hangs out next to your main window, which also talks to this agent, which is kind of a coordinator here. And we can also attach multiple other things here. For example, we have an IDE plugin in progress, which also talks to the agent. It can display state. It can send some inputs to the agent to retry reloading and things like that. So it's a very flexible architecture. Back to the demo. So far, we made small edits within this screen. Let's take a look at some other nice use cases for hot reloading things. Let's go into settings within the app and change the colors here to dark. And if I find the code for this, you can see that this settings screen is pretty empty. We only have the color switcher here. And the reason for this is that on desktop, we don't have notifications implemented. So there's this feature flag that basically disables them. But of course, with hot reload, if for development purposes, I want to have a quick look at what these settings look like, I can just do an if true here, wait for it to hot reload, and it will show me the notification settings that were otherwise hidden. The other thing that would be interesting to work on here and iterate a bit is this animation. So right now, if I change from light to dark mode, it's a kind of a basic animation. If we slow it down, maybe to 2 seconds, and then click it again, you can see that it's a very linear animation. That's the default easing here, right? So we can try playing around to find a more exciting, more dynamic animation. And there's a lot of easing options, as you might know in Compose. So it can take some time to find the correct one that feels right. You can try an ease in and out cubic, for example. Let's see what that does. So that has some momentum in the middle. So that's more exciting. Or I know that there are some elastic options. So maybe we can try ease in and out elastic. And wait for that to reload in a second. And well, that just looks kind of strange on the top. So probably not this one. And I also know that there's a bouncing option, so maybe that will work nicely. Wait for it to reload, run it again, and that's kind of fun. So maybe we'll just stick with this and probably stick with dark mode for the rest of the demo. I also want to emphasize here that these things, for example, weren't imported yet, so things like adding new imports to the file as you're working on it are also just fine with hot reload. And again, we stayed in the current screen, and we saw the changes almost instantly. If we keep hopping around in the app, we have a speaker list where we can search, for example, for all of our favorite Sebastians who are going to be speaking at KotlinConf. And if we hop into the code of the screen, we can see that each of these items are displayed by a speaker card. And if we go into the speaker card, we can, again, like try different things, different design ideas within this current screen. So let's say that we want to make the icons maybe a bit larger. So I can raise this to 120 dps. Now we see what that would look like. Or maybe we want it to be a bit smaller, and we can try that as an iteration. We can also hop into the speaker avatar as an example, and currently we're using rounded corners for each of these avatars. If I want to use circle shapes instead, I can just modify that, and now we can see what that would look like on the UI. These last couple steps were actually special compared to the previous reloads that we've done, because these components, the avatar and the little speaker card view, are actually part of a different module within the application. So these are in a separate UI components module, while everything that we did previously was in the shared module, which contains the main parts of the application. So hot reload really doesn't care about like which part of your code you're changing. It also works cross modules, because you likely have multi-module projects at this point. Let's keep moving with this screen and take a look at what happens when we make it larger. And well, we can see that it doesn't react too well to that, right? Like it's a flat list. It doesn't work too nicely on large screens. But if we hop back over to the speaker screen, we can find that this is implemented with a grid which currently has 1 column. So I can again start iterating here. I can try things like changing this to have 3 columns, which of course will work nicely on large screens, but not so nice on small screens. So maybe we want a different grid cell spec here. Maybe we want an adaptive grid, where we can give each speaker like 300 dps or so of space. And once that reloads, we can see that on a small screen, we have just a single column. And if I manage to grab the side of the window, it rearranges itself nicely when we change the screen size. What else can we take a look at on this screen? Right, so it might be suspicious for you that the thing that I started with here was a lazy grid with a single column, right? Like we wouldn't write this code in Compose normally. We would use a lazy column instead of a single column grid. And there is a reason why I didn't do that. And I'm going to show you by trying to rewrite this into a lazy column. When I do this, you'll see that the hot reload toolbar, which starts in orange, actually sticks around and becomes red. This specific change of going between a lazy column and a lazy vertical grid hits a very small edge case in hot reload at the moment. And if we take a look at the dev tooling, it will actually give us the detail of what's crashing. It will tell us that it failed to reload code because we have changed the superclasses of one of the classes that are involved. So basically, one of these lambdas here, one of these scopes that has receivers based on either the lazy column or the lazy grid, is changing its supertype while having the same ID as before. So there's a conflict there. This is basically the only case that hot reload cannot deal with, changing the supertype of an existing class. But again, you can generally change one component into another, like a box into a column into a row, dynamically as you want. This specific combo just happens to be something that hot reload, currently in its early state, fails on. But you can see that it recovers very nicely. If I go back to a grid, we again have hot reload running. We didn't have to restart or anything. So worst case scenario, you get a temporary error, and maybe you need to undo something. But nothing worse than that can really happen when using hot reload. OK, and of course, through all of these changes, important note that the actual screen state was retained. So again, we're on the same screen. We're in the search mode. We have the search query typed in. All of those things survived the hot reload steps. Let's go to a more exciting example as our final example here, which is going to be on the schedule screen. This is a large and complex screen. It's basically one huge lazy list, a lazy column, and it has a lot of different types of items in it. So it has all of the sessions of the conference. It has events like the party and the registration. It has these big day headers, and it has titles for each of the time slots of the conference. And all of these are represented by these schedule list items in the application, which is a sealed interface. And if we filter for just the bookmarked sessions within the app, we can see that, of course, I have the Compose Hot Reload talk bookmarked, which is going to be a great talk in just about a month with a lot of deep technical detail of how the invalidation logic works. So I can highly recommend catching that. But what we also see here is that there are time slots where I don't have any bookmarks at the moment, and they look kind of strange with just the time there and no details. So let's say that we want to add a new item to this list, and we would do that by adding a new item to the sealed hierarchy that we have. So I'll create this no bookmarks item as an example here. And I already prepared an if statement in the correct place within the view model code that checks if one of these time slots was created with no sessions in it, and then it inserts a new no bookmarks item to it. We can also, while this hot reloads, we can also check where this is being called from. So this is somewhere deep inside the view model. It's this long function that assembles our entire list. And if we look for its usages, we'll see that it's inside a stateflow combine sort of setup. So we're grabbing a bunch of data from different parts of the application and assembling all of that with the logic that we just added the new if statement into. Now, our code doesn't compile yet. We are just simply in a broken compilation state. We have a basic compilation error. So of course, hot reload shows us that it's currently in the red. And the issue is that we added a new sealed item to the interface. So of course, we have a when statement on all of these items that renders on the UI implementation side. So we need to make sure that we add the new branch to that. And if we scroll down to the bottom of the branch, we can actually add the implementation for the new item. So I'm going to add the text and say something like no bookmarks here for the current slot. And now hot reload will work, and it will correctly reload our code. But we don't see the UI change, right? So we don't see the new item that I was supposed to insert in these empty slots. And the reason for that is because we can only rerun your code for you automatically if it's directly within Compose, right? Because in that case, we can find exactly which groups, which lambdas, which scopes within Compose are relying on the code that you've just changed, and we can just invalidate the composition. But here we changed code that is inside a view model, so we need some way of rerunning that. And while we can't do that automatically, if we just make some user actions on the UI that will rerun the code, that will now use the new version as well. So if I just exit the bookmark view and I go back in, we can see that the new items appear because just changing the filter option re-executed the view model function, which now was using the new code. So Compose Hot Reload reloads everything and not just strictly your UI code, but we can only automatically rerun code that's inside your composition. And of course, from here, making this a bit nicer is kind of trivial given everything that we've seen. So we can add a new modifier. We can give it some color. We can use Kotlin conf theme, and there's a nice color for note text. And if I save that, of course, this is now a change within the composable code. So it will pop into place. It will have a nice color and some more decent padding. So with this, we have basically built a new feature, creating a new class to do that, adding that to a sealed hierarchy, which is, again, kind of a complex scenario, and, of course, implementing the UI for the new feature as well. Again, all without restarting. Let me show you one last thing before we run out of time. We have a theming setup in the app, which is very similar to how Material Theme works, except we built our own theme on top of the foundation layer of Compose. And again, it uses the same idea as Material. We are providing a bunch of values like colors and typography into the composition. And if we just go back to the top of our app, you can see that we have a bunch of these cars, these switchers, these events, which use this standard gray background. And we can actually hop into our dark colors and find the appropriate value, which is this tile background property. And if we want to make this a less transparent white, for example, we can do that. And again, Compose can follow the trace of where this is being used. Well, hot reload can follow that. So while this is the top-level property, first the property gets updated, then hot reload figures out that this is actually being provided into a composition local, and then it calls some invalidations in compose so that we can see the change. And of course, again, we can play around with this and iterate very quickly on UI. So if we want this to be maybe like a magenta instead, we can also do that. It will hot reload, and we'll see the new version. With that, I think we are done with the demo, and we are almost out of time. So let me quickly wrap this up. Compose Hot Reload is currently in alpha. You can find it on GitHub. Again, it's a plugin that you can grab and add to your application. And even though it's in alpha at the moment, it's already the most powerful reloading solution for Compose. It really doesn't make you change the way that you're editing or structuring your code. You can essentially do whatever you want with hot reload, and it will follow you and show you the latest changes. I have to advertise quickly that we're going to have an office hours again today for anything Kotlin related, whether it's KMP, language topics, server side, anything you want to ask about. We would love to see you in room 204 right after lunch, I believe. And here are a couple resources related to hot reload. So once again, the repository for the plugin itself, the Kotlin conf app, which is configured with hot reload, so you can clone the repo and play around in there. And we have a bunch of content from Sebastian Selmayr, who is the author of Hot Reload and who implemented this feature. First of all, he's going to have an excellent talk at KotlinConf, as I already mentioned. And he also has really good technical content on both his YouTube channel and on his personal blog. So make sure that you check that out. And I think we are just about out of time. So that's it for today. Please find me afterwards, or I don't know if we have time for questions. Do we have time for questions?
Hi, thank you. Just to be sure, this is JVM only, right?
Yes. So this is like strictly implemented on JBR with its reload capabilities. So you need a desktop JVM target to do this, which I think is completely worth it only to have hot reload. And of course, it's also a target that's very easy to build and run compared to anything else. Like you don't need an emulator, you don't need anything set up. You need like a JDK, and you're going to be able to build and run a desktop target. So it's a very good incentive to have, even just for development, even if you're not shipping it, just to have a desktop target configured. And we'll look into more platforms later, but the core of the implementation right now is based on the JVM. I think we had a question all the way up there. We still do. Excellent.
Thanks for the presentation. I really love everything what JetBrains does.
Thank you.
Yeah, really, I'm a big fan. I think my question got partially answered. Like you show, I was thinking it was kind of an emulator, but finally it's not. It's also part of the Compose Reload, like the pop-up you show with the app.
Yes, so the widget that's on the side of the app, that's the dev tooling window for Compose Hot Reload. So it shows you the reload state. It shows you like how many successful reloads you had. For example, we did 24 of them during this talk. And it shows you like error messages if your code doesn't compile or something like that.
Okay. Okay, thanks.
Yep. Thank you. Any other questions? There's one. There's one. I can answer questions until they kick us out.
During your example, you comment about notification screen for desktop. You check the notification was displayed when it's available, and for this example, you replace the condition by true. Is it possible to detect in real time you're running on hot reload? Like to have to enable some features if we know we are running on a hot reload mode.
Technically, yes, we don't really have anything for this, but the Gradle plugin will tell you if the current task that is running with hot reload or not. So you could technically check for whether you're in hot reload mode. You can, of course, also check if you're running on the desktop target, if you want just special handling for desktop. Like for notifications, we have that, for example, set up in the app.
Yes, okay. Thank you.